All right, here we go. Number one, answers. This is review 3, module 4, topic A, review 3. Here's what I would do. Divide by 2. Balance the equation. That's going to cancel out these 2's, and it's going to leave me with x minus 3 squared is equal to 6. And then take the square root to undo the exponent, balance the equation. So we get x minus 3 is equal to plus or minus square root of 6. And we have two possibilities here. The first is x minus 3 equals a positive square root of 6, or x minus 3 equals a negative square root of 6. Those are the two possibilities. And then we just solve for x, isolate the x. So add 3. And we get x equals 3 plus the square root of 6. That's one solution. And add 3 to both sides here. And we get x equals 3 minus the square root of 6. And that's our other solution. That's number one. Number two, very ugly. But really, we're just trying to isolate the k this time, isolate the variable. So how about subtract 20? That leaves us with a negative 8 is equal to a negative 2 times 5 minus k, and that is squared. And then before I can undo the square, I've got to get rid of this negative 2. So I'm going to divide by negative 2 from both sides. That's going to give me a positive 4 is equal to 5 minus k, and that's squared. Now I can take the square root to undo the exponent. So I get a plus or minus 2 is equal to 5 minus k. And then I have two different possibilities here, right? I could have a positive 2 is equal to 5 minus k. And I could have a negative 2 is equal to 5 minus k. And we just solve for both. So I don't know, maybe the easier thing to do would be to add k to both sides so it's positive. And then I would get k plus 2 equals 5. And then subtract 2. So k equals 3 is one solution. And I'd maybe do the same thing down here, positive k to both sides. That would give us k minus 2 equals 5. And then in order to isolate, I'd have to add 2. So k would equal 7, and that's another solution. K equals 3, k equals 7. All right? Third one, the length of a rectangle is 5 inches more than twice a number. Well, the length is equal to twice a number plus 5 inches more. 5 inches more. Let me retry that. There we go, 5 inches more. The width is 4 less than the same number, so the width is 4 less than x, so x minus 4. And then they told us that the perimeter is 44. Well, that just means that we would have 2 of the lengths, 2x plus 5, added to 2 of the widths. 2 lengths plus 2 widths is equal to the perimeter, which is 44. Now, distributive property, 2 times 2x is a 4x. A 2 times 5 is a positive 10. Plus 2 times x is a 2x. 2 times negative 4 is a negative 8. And that's all equal to 44. Combine like terms. Well, I've got positive 4x and a positive 2x. That gives us a positive 6x. And then positive 10 and a negative 8 gives us a positive 2. And that's all equal to 44. And then isolate. So subtract 2, we get 6x equals 42. Divide by 6, x is 7. What is the number? 7. All right, next one. A garden measuring 12 meters by 16 meters is to have a pedestrian pathway that's W meters wide all the way around it, increasing the total area to 285 square meters. What is the width of the pathway? Well, let's imagine we have a 12 by 16 walkway, and then we're going to add another walkway. Let me get a different color here so we can maybe that one. That's a nice color. Okay. So if I put a 4 by 4, or sorry, a W width pathway around it, maybe it looks like this, right? We don't know how wide it really is, but maybe it's like that. And then wouldn't it be true then that this distance from here to here, wouldn't that be 4? Oh, sorry, I keep wanting to say 4. I don't know if the answer is 4 or not. Wouldn't that be W feet? And then from the left side, from here to here, wouldn't that also be W feet? So if the original was, or sorry, not feet, meters. If the original was 16 meters, I just added a W on the left side, that distance, and a W on the right side. So wouldn't that be 2W plus 16? That would be the length. And then if the width, if we think of the same thing on the width, well, from here to here is W, and down here, from here to here, that's also W. So if the original width was 12, well, then the new width would be 2W plus 12, right? Because we added this W and this W, whatever that distance is. So there's my length. This is my length, and this is my width. So now the new total area is 285 square meters. So length times width will give me the area. So we're going to take 2W plus 16, and we're going to multiply it by 2W plus 12, and that's going to equal 285. All right, so FOIL, this is 4W squared. And then I would have a 24W. Right there, 2 times 12 is 24W. And another 32W. So let's write that out. That's a 24W plus 32W. And then 16 times 12. Well, I'll have to calculate that. Let's see, 16 times 12. 16 times 12 is 192, so this would be a plus 192. And that's still all equal to 285. Now I can combine like terms. I would have 4W squared plus 56W plus 192 is equal to 285. Well, I'd like for this to be the zero product property, so how about subtracting 285 from both sides? That would work. Okay, and if I do that, I get 4W squared plus 56W. And then 192 minus 285 gives me a negative 93. And then that's equal to 0. All right. Now I would like to factor, if at all possible. Let's see if we can do this. It's not going to be pretty, is it? Let's see. Let's use our X method. Well, 4 times a negative 93, so negative 93 times 4 is a negative 372. And I want to add to get a positive 56. So some way to multiply and get 372. Oh, my goodness. Fun. All right, let's figure this out. All right, well, it turns out that 6 times 62. 6 times 62 is 372. I want it to be negative, but I want when I add to be positive. So it's going to be a negative 6 and a positive 62. And then my A value is a 4. A value is a 4. If I simplify, I would get a negative 3 over 2 on the left side. And over here, 62 divided by 4. No, but 62 divided by 2 I could do. So this is 31 over 2. Okay, so factoring. We get 2w minus 3 and 2w plus 31. And that's all equal to 0. Then we can solve for our each one of these. Well, I know that my answer is going to have to be positive, and the only way that it's going to be positive is if I use that binomial. So if I set 2w minus 3 equal to 0 and add 3, that gives me 2w equals 3, and then divide each side by 2. And that gives us W equals 1.5 meters. And that's the width of the pathway, W, 1.5 meters. The other one's going to give me a negative value, and the width of a pathway cannot be a negative number of meters. So it's got to be that one, 1.5 meters. All right. Next one, the given quadratic function. We have to find the, wow, where did my stuff go? We got to find the y-intercept. This one will be for the y-intercept. This one will be for the x-intercepts. And then the axis of symmetry. So the y-intercept happens when the x value is 0. So the y-intercept happens when x equals 0. So I'm just going to plug in a 0 and find my y. So this would be 0 squared minus 3 times 0 plus 10. And 0 minus 0 plus 10 is just 10. So the y-intercept is when y equals 10. So the y-intercept is when x is 0 and y is 10. All right, that's my y-intercept. The x-intercepts happen when y equals 0. So when y equals 0, we get our x-intercepts. Well, I'm going to take the equation and change my y, or f of x, into a 0, and then solve for x. So there's my function, and then what I would like to do is factor. So this is going to be an x, and then I need a way to multiply to get 10. How about 5 times 2, where 5 is negative and the 2 is positive? That will give me a negative 3 in the middle. That's all equal to 0. And then I have my two x-intercepts. If I set x minus 5 equal to 0 and solve, I get x equals 5. So that ordered pair would be when x is 5 and y is 0. That's an x-intercept. And then if I set x plus 2 equal to 0 and solve, I get x equals a negative 2. So that is negative 2 comma 0. That's an x-intercept. Okay, and then the last part, find the axis of symmetry. Well, that's the middle of my two x values. So I'm going to take my first x value, and I'm going to add it to the second x value, which is a negative 2, and then I'm going to divide by 2. So 5 and a negative 2 gives me a positive 3, and half of that would be a 1.5. So the axis of symmetry is when x equals 1.5. And I could go a little further to find the vertex by saying, well, what if x is 1.5? And then plug that into my original function, and then solve for y. Then I would have my vertex. So I'm going to do that as well. I'm going to do that down here. So I'm going to say my y value is equal to 1.5 squared minus 3 times 1.5, and then plus 10. So the first thing I need to know is 1.5 squared. That's a 2.25. And then a negative 3 times 1.5 is, 3 times 1.5 is 4.5, and it's negative, so it's a negative 4.5. And then that plus 10 is on there. So then just add those all together. 2.25 minus 4.5 plus 10. And we get y equals 7.75. So there's my vertex. The vertex is when x is a 1.5 and when the y is a 7.75. That's the vertex. All right. One more, graph the following function and identify the key features of the graph. So we're going to do the exact same thing that we did there. We just don't need the y-intercept, but the x-intercept is important. So let's do the x-intercept first. X-intercept. And we're just going to put a 0 in for y. When y is 0, that will be where the line crosses the x-axis. So that's 2x squared plus 4x minus 16. And I'm going to factor out a 2. So I see 0 is equal to 2 times x squared plus 4x divided by 2 is 2x. And then negative 16 divided by 2 is a negative 8. Okay, and then I can factor. This will be x times x, and looks like a negative 2 and a positive 4. So there are my x-intercepts. It's going to be when x is a positive 2 and y is 0, and when x is a negative 4 and y is 0. So there are my x-intercepts. And now that I know my x-intercepts, I can find the axis of symmetry. Okay, and in order to find the axis of symmetry, I'm going to take my two x values and add them together. So I get 2 plus a negative 4, and then divide that by 2 to get the middle, or the average. And that gives me a negative 2 over 2, which is a negative 1. So my axis of symmetry is when x equals a negative 1. And then finally, I would like to know the vertex. And in order to find the vertex, we just say, well, what if x is negative 1? So we go back up to our original equation and we rewrite. I'll put it over here because we won't have to graph it. 2 times a negative 1 plus 4 times a negative 1. Oops, that negative 1 is squared, the first one. And then minus 16. Well, negative 1 squared is 1, and 1 times 2 is 2. And then 4 times a negative 1 is a negative 4, and then we have the negative 16. Positive 2 and a negative 4 is a negative 2, a negative 2 and a negative 16 is a negative 18. So when x is negative 1, the y value is negative 18. That is the vertex. All right, that's all we need. X-intercepts helps us find the axis of symmetry. The axis of symmetry helps us find the vertex. And that is review 3. Hope that helps. See you next time.